Aloha guys, this is Dr. Tom Walker coming at you from the Hawaiian Islands. We're here for another fascinating discussion about strange energy and a strange world. Okay, when we ended the previous tape, very suddenly, we were talking about zero-point energy or quantum vacuum energy. And we're talking about we were talking about how the mathematical equations predicted enormous amounts of energy that couldn't really be there. And the reason is if there were that much energy after the Big Bang, eventually the expansion of the universe would have been logarithmic in scale and would have expanded out faster than, with no time allotted to make solar systems and the other things necessary for life. So obviously that didn't happen. However, there is a vast amount of energy. Scientists think at least it's a little above zero. So here's an example where the mathematics is there, but we just know it doesn't apply entirely. Okay, so we've talked about dark energy, we've talked about the cosmological constant, and we've talked about zero-point energy. So all this mystical primordial energy out there, which one is it? Well, are they different? Well, yes and no. Are they the same? Yeah, no, maybe. It depends upon who we ask. Research the subject a bit and you'll see both answers. The bottom line is that this energy makes up 70% of the universe, and we basically don't have a clue what it is. It's an inherent quality of space-time, a part of the fabric of reality itself. In spite of the stupendous values demonstrated by the equations, it must have a value a little above zero. Why? For what we talked about a moment ago. Most shocking of all is that it's anti-gravity in nature. Since the acceleration of the universe is speeding up, dark energy must exhibit anti-gravity to push everything apart at an increasing velocity. Equally as shocking is the finding that it's a constant. It's the same everywhere throughout the cosmos. And as the cosmos expands, more of it pops into existence from, quote, nothing, unquote. Nobel Prizes have been awarded for these discoveries, the most recent in 2011, but it still remains a profound mystery. Now we have more to the story. We have what QFT, or quantum field theory. The thinking here is, guys, is that for every elementary particle that exists, each one has their own separate and distinct field. And from this field, this energetic field, is where the particles manifest themselves from. In case you haven't caught the drift here, let's talk about that. According to the most accepted, the hippest scientific theory, when most of the time everything is some energy that we don't really know what it is and we don't understand it, and under certain conditions this energy condenses to form what we call particles. The particles exist in the energy as virtual particles. And when they're measured or observed or influenced in some way, they pop into existence. The state vector collapses, as it's called. So this cosmological constant and this dark energy and zero-point energy and now QFT, quantum field theory, are all basically the same thing. So let's see what it says. We're not going to talk about quantum mechanics, not now anyway. Good. We're going to discuss quantum fields, though, because they're relevant to our discussion on energy. According to a widely accepted part of quantum mechanics, particles like photons, light, electrons, mass, form from a vast complex of quantum fields that exist throughout the universe. Each of the 17 elementary particles in the standard model of physics is said to have its own field. There are also separate fields for gravity and electromagnetism, light in other words. They oscillate and interact with each other. If everything else is removed, the quantum fields remain, comprising the vacuum energy. A special quantum field is the Higgs field, also existing everywhere. But Higgs is special, and it's said to be the energy field that gives mass to matter, or to particles. Each field has its own particle, or quantum. Force fields are comprised of quanta called bosons, specifically photons and gluons. Now, we're not going to go any further than this into particle physics. Matter fields quantums are fermions, electrons, and quarks. The Higgs field has the Higgs boson, the so-called God particle. The Higgs boson was finally detected by CERN's Large Hadron Collider on July 4th, 2012. However, since then, there's some controversy of whether it was actually discovered or not. Down the road here away, I've already videoed or produced a number of these for recording. We'll talk about because it's very interesting, the amount of time and money and effort it took to detect the so-called God particle. So, in addition to the other energies, we now add quantum field theory. Where do particles come from? If we research and ask questions like, are dark energy and zero-point energy the same, we basically find the answer to be yes. The same is generally true for quantum field theory, QFT. They keep coming back to a universal unknown energies present everywhere and the cosmological constant. The particles that make up you and I are said to appear from quantum fields. There's a field for each particle, as we stated previously. When the fields are, quote, given energy, or the energy is concentrated in specific points, particles result. According to the most accepted version of quantum mechanics, the Copenhagen interpretation, we mentioned that last time, particles appear from the action of being observed or measured. My great hero Einstein was not happy about that at all. And one evening he was walking home to his home in Princeton, New Jersey, with his friend Abraham Pace, I think is how you pronounce that. And Einstein, who was he was not happy at all about most of quantum mechanics, said, "Do you really believe the moon only exists when you look at it?" However, as absurd as that might sound, there's reason to think that this is generally true. Naturally, this brings up the question of consciousness and reality. Does it require a conscious being to summon the virtual particles into reality? Officially, no. A camera can do it. But there are many who think consciousness is fundamental. In fact, many of the founders of quantum mechanics thought so. Also, too, guys, we'll mention this again. I know you get tired of hearing that. But yeah, we can take a picture of the moon and demonstrate that it's there. But it still requires consciousness to interpret the photograph, to process it, look at it, focus on the retina, send the nerve signals back through the optic chiasm to the occipital lobe of the brain for processing. Here's the 17 elementary particles of the Standard Model. Here's the Higgs boson, the God particle. We're going to talk about that down the road because, as I said a moment ago, the amount of time and effort that went into that and the amount of expense. And as of now, there is some controversy. Matter can be dark too. Now, we've talked about dark energy. Dark energy makes up most of the universe. But yes, we have dark matter also. In the 1930s, astronomer Fritz Zwicky was observing the Comet cluster of galaxies. He noticed there was about 500 times more mass than what the great Edwin Hubble predicted. He called it dark matter. In the late 1970s, astronomer Vera Rubin, here, was studying the motion of stars in the outer spiral arms of the Andromeda galaxy. She discovered that the spiral arms were rotating at about the same velocity as the center of the galaxy, something that violated Newton's gravity in a big way. Gravity fades at the inverse square of the distance from its source. You all knew that. So the spiral arms were many light years out and should have rotated much more slowly. But they didn't. Subsequent studies showed that this was true of most all galaxies, including our Milky Way galaxy. The only way this could be true is if there were a massive amount of missing matter somewhere. So again, they came up with dark matter. Dark matter was confirmed, sort of. After 40 years, we still can't see it. It emits gravity, but nothing else. No light, no radiation. There are no particles associated with it. Like dark energy, dark matter remains a profound mystery. Okay, let's have a little fun. I found this after I'd already put this together. A cartoon. Along with antimatter, dark matter was recently discovered. And dark matter, we've recently discovered the existence of doesn't matter, which appears to have no effect on the universe whatsoever. I thought it was funny. Actually, it is very clever. Okay, these numbers vary a little bit, but the content of the universe, most of it, is, I know a minute ago we said 70%. 68% is dark energy. We have no idea what it is. Sort of. The other 27% is dark matter. We have no idea what it is. It doesn't emit electromagnetic radiation or anything other than just gravity. Everything that we know and love, that we are aware of, or we're aware of, comprises only 5% of the known universe. Actually, it's most sources say 4%, but I thought this was a good little photograph or a drawing to put in here. Our entire universe is a mystery. No particles of dark matter have ever been discovered. Dark matter was found to have 6 times as much gravity as all the mass in the observable universe. So for some reason, it's heavy on the gravity and nothing else. It interacts weakly with itself in regular matter, so it distributes evenly throughout space. It doesn't clump up. All we can see of it are its gravitational effects. So again, dark matter comprises 85% of the mass in the universe. Only 4% of the universe is visible matter. The rest is dark matter and energy. Only 15% of the visible matter in the universe, or of the 15%, only 4% of it are stars and galaxies and stuff. The rest of it, 11%, is interstellar gas. We keep slicing the pie more narrowly all along. This means we have almost no idea what the vast majority of the universe consists of. It remains a total mystery comprised of matter and energy that are undefined. Only 4%. That's right. All the wondrous galaxies, black holes, quasars, solar systems, and everything else we know and love comprise only 4% of the universe. This has been known now about 25 years. The rest is the vast unknown. Now, while I was researching my book in the 90s, where's it at? Dun, 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 dun. Yes, the Force is with us. This had just been discovered, and the expansion of the universe was just now being discovered. So here's what I put. Well, this was discovered while I was researching the Force as with us in the 90s. The Force is with us. It blew minds around the globe. I included it in the book because it's so important. Scientific America had this to say in the article, Surveying Spacetime with Supernovae. Exploding stars seen across immense distances show that cosmic expansion may be accelerating. This is before it had been completely confirmed. A sign that the universe may be driven apart by an exotic new form of energy. In a companion article, Cosmological Anti-Gravity, physicist Lawrence Krauss said, the long-derided cosmological constant, a contrivance of Albert Einstein that represents a bizarre form of energy inherent in space itself, is one of the 2 contenders for explaining these changes in the expansion rate of the universe. Krauss continued. The force caused by the constant operates even in the complete absence of matter or radiation. Therefore, its source must be a curious energy that resides in empty space. The cosmological constant, like the ether, endows the void with an almost metaphysical aura. Like it or not, empty space is not so empty after all. Now, this is a leading physicist, guys, mainstream or scientific orthodox club. The cosmological constant, like the ether, endows the void with an almost metaphysical aura. It wasn't long before scientists were convinced that the expansion of the universe is accelerating. What most surprised me as I read this a quarter century ago was Krauss's use of terms like ether, which is, it was the Michelson-Morley experiment. So if you know about that, was disproven, although it's interesting that a prominent physicist would toss that out again. Curious energy, metaphysical aura. It sounds like descriptions of the cosmos from the Chinese and other ancient civilizations. Perhaps the Force is with us after all. And this will be the topic of our next lesson. Guys, when most of the vast majority of the universe is unknown and not understood, and a singularity, for lack of a better term, seems like you might want to cut some slack to ideas that are on the fringe that might fit into something like that. Okay. Stay tuned. Next time, we're going to talk a little more about this strange energy. So, I will meet you out there in the ether. This is Dr. Tom.